Okay, let us continue with knowing the capabilities of unlock discovery. In the previous video, we have seen actually how do we see 2 volt that is applied from wave gen 1 at channel 1. So let us try to apply a sine wave of certain frequency. Now this is a sine wave. So now this is a sine wave of 1 kilohertz and an amplitude of 1 volt. Now you can see it's already coming over here. There's offset of 2 volt. Let me put an offset of 0 volt here. Now what I'll do is I'll change that. Now I'm just editing the value, so I can make it 0 now. Now you can see the offset is 0. Now you can see it has shifted down. So this is the signal has got no offset. If you don't want to see second channel, you can just actually disable this channel too. Now you can see you are seeing only a sine wave of 1 volt amplitude with a frequency of 1 kilohertz. You can see the C1 maximum is almost 0.982 volt, which is approximately 1 volt amplitude. You can also measure the frequency of this. Go to this add option, defined measurements, and then this is channel 1. So because frequency is a time dependent one, it will be a horizontal parameter. So let me select the horizontal. Here you can see I got a frequency. Just double click on frequency. You can actually have the display of frequency, which is 9, okay, almost 1 kilohertz. So I can just make this, highlight this, and if you can see a frequency of 1 kilohertz and amplitude of almost 1 volt is the signal. Now if you want to view it more clearly with more clarity, you can actually change the range to 0.5, which will make a signal with more clarity. If you want to change this times per division, if you want to see only 2 cycles, so you can still make it something like this, so that you can clearly see the waveforms. Now it is a pure signal of only 2 cycles have been displayed now. So with sufficient amplitude, so that you can see the amplitude also. Suppose instead of having it as 0.5 volt per division, suppose if you choose an amplitude of something like 5 volt per division, so it will be not a good idea to see the waveform something like this. Whenever the amplitude reduces, make sure that your volt per division is suitable enough so that it occupies almost 80% of the screen. So let me just choose it as 0.2. If I choose 0.2, it will go up to almost 100% of this. Now you can see this is a very good way of observing the waveforms. Now we are just seeing only channel 1. So what I'll do is I'll just apply the second channel also. I'll replace the second channel also from WaveGen, which is over here. You can also see there is one more option called as simple and basic. I'll just use this basic. You see the difference. If I use this basic, I'll have a possibility of changing the parameters through this swiping bars. Now you can see if I change this, it's actually changing the frequency. Now I can see if you can see on the left hand side, you are having more and more cycles coming up in the scope. So now it is a frequency of almost 35 kilohertz here. Now you can see that is exactly displayed here as 35 kilohertz. You can also change the amplitude. So I'm changing the amplitude now. So now you can see the amplitude is almost 1.8, which is not seen now. So why means because this volts per division is not proper. What I'll do is I'll suitably adjust this volt per division. Now you can see it is almost 1.74, which is 1.86 is the voltage. This is okay, fine. 20-30 millivolts of difference is okay in the measurement. So now you can see it is 35 kilohertz signal, and now this is how you can actually have either simple or basic option while selecting the waveGen. So let it be always simple so that you can able to easily change the parameters. Now let me select second channel also. Let me just select channel 2 also. We'll be selecting okay channel 1 as well as channel 2. If it is green means it is off. So now it's not giving any signal, that's why there is no signal over here. So let me turn on both of them. So let me just run both channel 1 and channel 2. So that's what is happening now. So this is, let me apply a square wave from channel 2, that is waveform 2, which is now applied to second channel of the scope. So I'm just, let me enable the second channel of the scope also. Now you can clearly observe, so we are actually using both the channels of waveform, that is waveform 1 and waveform 2, and we are using two channels of the oscilloscope, that is channel 1 and channel 2. Channel 1 is connected with sine wave, channel 2 is connected with square wave. So both are of frequency 1 kHz and both are having 1 volt as the amplitude. But here you can see this is looking like a bit large in amplitude because this volt per division is 0.5, here it is 1 volt per division. If I make this also 1 volt per division, it is going to exactly coincide with the sine wave. You can see the peaks are almost the same. Since the frequencies are 1 kHz, so we are having they are exactly matching. So now I can, it's also possible to give the desired DC offset to any of the waveform. Assume that okay, let me give an offset of 2 volt to this. Now you can see this will going to shift up by. So this reference which was there at 0 has now shifted to 2 volt. So there is a DC of 2 volt being applied to the square wave. So I can also have a square wave of different duty cycle. It is now it is symmetric now. It is 50%, 50%. I can make it 30% as the on time and off time is more now. Now you can see it is 30%. Now it is 70% is off time. All these measurements can be done on this oscilloscope also. What I can do is, let me just see how do we use that. Now let me again add define parameters. Let me measure what is the positive duty cycle and negative duty cycle of the square wave. So since the square wave is there in channel 2, so this is channel 2, go for horizontal, double click on horizontal, we have the frequency, double click on that, you can whatever parameter you want to observe or to display, you just double click on that. So it is positive duty cycle, click on that, and you have negative duty cycle, you have positive width. This is in terms of percentage, whereas this will be in terms of time. So width will be in terms of time, whereas the duty cycle will be in terms of percentage. As you can see here, 29%, and you can see 70%, and you can see the width is 0.3 millisecond, this is 0.7 millisecond. Now these are the timings and the percentage of any parameter that you have selected. So you can either measure channel 1 parameter, channel 1 signal or channel 2 signal. The parameters can be either x-axis value or y-axis value. In x-axis you have so many parameters like frequency, width, time period. In vertical, in y-axis you have got what is maximum amplitude, minimum, average, RMS value. So there's a lot of parameters you can able to measure over here. So whichever you just type on that, double click on that particular value, you can see now you are seeing the average value of channel 1, which is this sine wave. You can see average value is almost 0, it is 0.01. So it's almost symmetric, it's a pure sine wave. So this way we can effectively apply any signal and we can able to measure this. And if you want to make note of any of these values, what you can do is you can simply take a screenshot of this particular screen and you can submit this along with your report. So this can be a part of your report to attend that okay, you have done the experiment. Of course, you can simultaneously vary the parameters, as I said. So what I can do is I can make this as basic. I can make this as basic, By default it will come like a sine. We make it square, and then you can see the corresponding things you can change. Now it is square wave. You can see now we can change the amplitude. I can say I change the amplitude to 2.3. You can change. I can increase the frequency of the square wave to a larger frequency. You can see there's a change in the frequency of the square wave. So all these things can be easily done. Now it's almost 92 kilohertz is the frequency. You can see this frequency C2 belongs to 92 kilohertz. Likewise, now it has become very easy and effective for the user to use this analog discovery for applying and measuring any signal of his interest. So signals can be any of these type. It can be DC, sine, as we explained last time, and you can also measure many parameters. So this will be a very handy tool for students while doing the experiment, because that will going to save a lot of time, and you can comfortably do the measurements. So in the next videos we shall see how do we use the static IO, especially for doing digital experiments where you have to apply zeros and ones in the form of 5 volt or 3.3 volt, that is logic high and logic low, and try to find out how do we use LEDs for measuring that logic high or low. Okay, that's it for the second video. Just enjoy using analog discovery and then start exploring the beauty of analog circuits.